Hey everyone, I just wanted to make another video here where we kind of talk about one of these special cases that may come up when you're using antidifferentiation by parts, and that is called solving for the unknown integral. So let's say we have this integral right here. We have e to the x cosine x dx, and we want to go ahead and find the antiderivative, so we're going to go use integration by parts. So in this case here, I'm going to let u equal e to the x, and I'm going to let dv equal cosine x dx. Okay, and again, remember that our integration by parts formula is the integral of u dv is equal to uv minus the integral of v du. And it comes from our application of the product rule. So that being said, now I need to know, okay, du is going to be simple. The derivative of e to the x is simply e to the x dx, and dv is simply going to be v is equal to the antiderivative of the cosine, which is the sine of x. So go ahead and we'll put that into our antidifferentiation by parts formula, and we get the integral of e to the x cosine x dx is equal to u times v, which would be e to the x sine x, minus the integral v du, so that's going to be sine of x times e to the x dx. Okay, and so now we go ahead and we look at this part right here, and it looks like we're going to need to use differentiation or anti-differentiation by parts again, just for that part right there. So we'll go ahead and we'll follow the same pattern. So u will once again equal e to the x, meaning that du is going to equal e to the x dx. Okay, we'll have dv is equal to sine x dx this time, meaning that v would be the antiderivative of the sine of x, which would be the negative cosine x. And so we'll go ahead and we'll put all that back into our formula here. So we'll get e to the x. Let me go back to my blue color there. So we'll get the integral of e to the x cosine x dx is equal to e to the x sine x minus, and this is going to be u times v, so minus is going to be a negative e to the x cosine x, negative e to the x cosine x, minus the integral of v du, so that's going to be a negative v du is going to be negative e to the x cosine x dx. Okay, and so I'm just going to go ahead and rewrite this, sort of fixing my signs here. I know if I distribute this negative, like those will cancel out. I can pull this negative out here and then multiply by that negative there, and so that sort of, I have three negatives, so that one's going to stay negative. So let's just go ahead and rewrite this, taking care of those signs. So we're going to get the integral now of e to the x cosine x dx is equal to e to the x sine x plus e to the x cosine x minus the integral of e to the x cosine x dx. So really what we find here now is that this this integral right over here is the same integral that we have on the left side of the equation. So we're kind of back to where we started now. So what I don't want to do is I don't want to just keep going and kind of keep going in this endless loop. Instead, what I'd like to do is just add it to the other side. So we're going to add this to the left side. So we'll get 2 times the integral of e to the x cosine x dx is equal to e to the x sine x plus e to the x cosine x. Okay, and what I'll do now is I'll just divide both sides by 2, and we can come up with our final answer, where we can say that the integral now of e to the x cosine x dx is equal to 1/2 e to the x, if we just kind of factor that out, times sine x plus cosine x, All we have to make sure that we include now is that constant of integration at the end, right? We still need that plus c. But basically what we get now is that integral, which we were having a hard time solving because it kind of reappeared in our process here, we would just, if we kind of just kept going by parts, we'd just end up with this endless loop where we just keep doing the same thing again and again and again and again. What we can do is we can call that the unknown integral. We just add it to the other side, so we have two of them on the left, and then we divide out that 2, and we're all set. So it's just one of those things. It's kind of a special case that may come up from time to time as you do in anti-differentiation by parts, so you want to be aware of it. And the way you get around it is when you get this integral that you originally started with, just add it over to the other side, divide by 2, and kind of go from there. So I hope this video helps. It's definitely something to be aware of as you use anti-differentiation by parts and the anti-differentiation by parts formula. So hopefully you recognize that when you see it. All right. Good luck, and I will see you in the next video.